requirement that must be achieved, and you need to prove that you have implemented a system which achieved that requirement. On the other hand, if you say that investor system should, it means is nice to have, is not a must. So that's why, if you remember at the beginning of the talk, I talk about the structured way of doing these requirements. So, which means that you need to have a specific language on how they have been structured. And there is a guideline on how to write these requirements. There's something called boilerplate, where I give a standardized form of writing the requirement. So when you read the requirement, you know that is atomic and it doesn't have any ambiguity. Yeah. So now, after I've finished about the high level requirement, now I'm moving in what are the tools used to manage these requirements? Because like I said, they should have specific tool we use to manage these requirements. So before I jump into the specific tools and look on the tools which we are using, I just want to showcase what are the key features required on those tools. So which we say that requirement management tools, essential features. What are the key features on those tools? So some of the key aspects of those tools, when you select the tool, imagine you set up a new business and you are doing some product development and you want to buy these tools for requirement management. So you need to buy or to get the requirement tool which is easy to use. So the idea is you need to make sure that it has forward functionalities. And then again, it's intuitive to the user interface, because I come across some tools which are not user friendly. So you need to have tools which are user friendly and you can interact easily with those tools. It's similar to mobile phone, really. You may have some mobile phone, they're pretty easy to find their settings, pretty easy to find their feature. So similar with this tool, when you interact with them, if you were to, link the requirement or write a requirement, it should be quite straightforward in terms on how you use that. When you review the requirement, the interface should be quite intuitive. And then again, you should be able to customize, because these tools, they come up with so many different features, but you need to be able to tailor those tools as per your organizational needs. So which means that you should be able to customize those tools, yeah, for your needs. So they should have some customization for specific. Yeah, that's why different company may use the same tools, but it may be tailored for the need of that company. And then again, they should have some mechanism to automate requirement gathering, yeah, because you want to improve the efficiency and reduce manual work. So which means you can save time. You can also reduce human error, because what we have seen, like when you use certain tool and then humans are keep adding their inputs, you may be subjected to human error. So we need to have some mechanism also to automate some aspect. Yeah. And then these tools also, they should be adaptable to the process and a process within the business. So the idea is like they should bring the flexibility to the workflow, and also they should be affordable. So you don't want to buy a tool which means like it's quite expensive to license it. Yeah. So you need to have mechanism to get the tool which is you can license and is affordable basically. So, and we fit with the budget, because we know that all the projects need to have budgets. And in that case, you want a tool which fit with your budget, and pricing structure consideration as well. Collaboration. So this is one of the key elements. Especially in the big organization, you may have multiple people working on the same tool, which means you need to have mechanism that multiple people can work together. They can either assign different tasks. Maybe one is working on, you see there, I was talking about 4 different components: electric machine, inverter, and DC-DC as well. So which means you may need to assign different tasks for different individuals. So you should have mechanism that multiple people can work on the same tool at the same time. And they could do real-time updates. Yeah. So the idea is like, we could be sitting one person in Tanzania, one person in India, one person in UK. We should be able to go to a central area and then work together in real time, update our area or add some comment on that too. Another area is how do we manage a repository of those requirements? So the requirement, they shouldn't be in individual local machines or individual computer. They should be somewhere in the database in a certain repository where anybody in the business can access those requirements and interact with those requirements and update them accordingly. And again, yeah, so that's the central location of the requirements. And then integration with other tools. So because the thing is, these tools, you may have one tool for requirement management, you may have another tool for testing, you may have another tool for software development and so on. So in order to get the traceability of the requirement and implementation and so on, that tool you select should be able to interact with all the tools. So it's quite critical to ensure that the tool also interact with the other tools. So the idea is it help you to streamline the workflow and also enhance the efficiency. Yeah. So if you have one tool, you don't, they interact to each other, you can also enhance efficiency. Traceability is another key aspect. I think I touched traceability several times. So we need to be able to do the bidirectional traceability. If you are writing requirement in one tool and you are writing your software in another tool, you should be able to show that this requirement written on that in this given tool is also traced on that one. So, and that one can come by if you can achieve integration with other tools. So you achieve the traceability. And basically, you track your requirement from when they were raised till when they were being completed. Another element, these tools, they should also be able to show the verification and validation, which means you can link with the testing and the validation of those testing. So which means when you write the requirement, you also need to write test cases to prove that those requirements, they are being tested and validated. So they should be able to have some linkage on that too. So these are the two key essential features when you select the tools. So let's look at what are the tools in the market. There are so many different tools in the markets for different industries, and also you may find some of automotive, they are using those, IBM those. You may have some company they're using Dassault tool systems, Siemens, Jira, and all of that, and Simulink as well. So you can see if in a traditional way in academia, you won't see these tools and you won't hear about these tools, except Simulink is the one used in teaching. Some of these tools you tend to know once you move into the companies. Yeah, for the sake of time, I'll just showcase only 3 tools. I'll showcase the IBM DOS, Dassault system, and Simulink. So that's how the tool will look like. Yeah. So that's how the tool will look like in terms of structure. So it will have different tabs, and you see here is a tool, which is those, but you can see MATLAB. So which means it have one part which has showed you about interaction with other tools, which means it means somehow you can link those to MATLAB, or you can export the requirement from those to MATLAB. You can also do change management. You can also do some analysis of the requirements and also other tools here. Yeah. And there is a format on how these requirements are structured. For example, here you can see this is an example of showing like section for engine speed, throttle angle, mixing, and so on. Yeah. And which means this requirement will be either in a review state or complete state, so that other people will pick the requirement and start working on those requirements. So that's how those look like in high level. Within the those also you can define use cases diagram. So for example, here in a use case diagram, you could say, okay, who are the actors? You could have a driver is your actor, but which system does the driver interact? You could say that the driver is interacting with the control of the vehicle direction, or it could interact with the gear selection. The driver could interact um, with the vehicle acceleration. So this, for example, the use case diagram, this basically the kind of part of the system engineering artifacts. Yeah, so I think I touched about the requirement, but the same tool could also use for the other artifacts of the system engineering, which is use cases. Yeah, the idea is to help you visualize the system you are designing. And another tool, which is we call it a DASO tool. And for the requirement management, we use this is called TRM. So TRM again does what DOS does. It's the same tool, but just different, kind of, always going to have different tools. It's similar, like you have an iPhone, you have Samsung, and so on. Yeah. Which means Samsung and iPhone, they could do similar stuff, yeah. Maybe some different in how you interact with them, but the primary function will be the same. So this is similar to that. So this TRM is similar to those. So again, you have some of your requirements, and that requirement will say what is the requirement? What is the maturity of that requirement? For if it says in work, it means it's not been completed, it's not been released. So basically, the software team shouldn't start working on it because it's still in work, in working condition, is in progress. And here I show you the number of revisions, how many times it's been reviewed, and what's the priority of that requirements, and what classification of the requirement. So you have some functional requirement and non-functional requirement. And when was it created, for example, yeah? And what is it for, yeah? So when you define the requirement, you need to do the declaration of what is it for, what is it trying to do. This one is adaptive cruise control. And you see it's high requirement and so on. And it could define like who is responsible, yeah, for that requirement. So those are the attributes of those requirements. So moving on, you could also use DASO tool for other stuff. I just put this one for completeness, just to show you the power of this DASO tool. So you could use the DASO tool for 3D experience. So you see here, you could model the entire physical body of the vehicle and having emulate and see different parts of the vehicle. Yeah. So not only for the requirement management, but you could also use for other stuff. Yeah. But now you may use Simulink as well. So Simulink is a good tool. You could do requirement directly in Simulink, or you could import requirement from other tool into Simulink. So I won't spend much time in this slide. Now, so we have spoke about requirement elicitation, and then I went to speak about the requirement, high-level requirement uh, definition for the system. And then I showed you some tools used for the requirement capturing and so on. Now we are moving to the system architecture design. So we are still in the left-hand side of the V, if you remember, and in the left side of the V, we started with the requirement elicitation, requirement system definition, high-level requirement system definition. Now we have moved to the system architecture design. So what is the system architecture design? So the system architecture design now, because you already have your system requirements, now you need to decompose those requirements into subsystem and component. And you define how does that system interact. So the idea is, if you remember, as a part of the requirement, I went through a couple of the example of electric machine, electric motor. I gave an example of the battery, inverter, and so on. So in this case, you may define and say that, okay, I will have subsystems, and in those subsystems, as a part of electric propulsion subsystem, I will have a power conversion subsystem. I will have electric motor subsystem. I'll have electronic control subsystem, and so on. Yeah. So you may have a subsystem, for example, for energy sources subsystem, subsystem for auxiliaries, subsystem for the propulsion, and how they interact with the external world. So that's how you do in your architecture design. You take your input, which is the requirement, and using the requirement, you now define the subsystems and components. Yeah, in order to meet that system. Yeah. And then the next step, once you have defined the system structure, you do the allocations. Because now you have a set of requirements. Now you need to allocate those requirements to a given subsystem or component. And also you need to do the interface definitions. And then once you have done that, you're moving on, you define now the behavior. How will subsystem interact with an external world or internal systems as well? Yeah, is in this case, for example, you may use to define for behavior of the system definition. We sometimes use state flow machines. For example, from here you can see it showcase on how you could do the gear selection. And this is a typical on how your gear selection happen in a vehicle. You will have your first gear entry, second gear entry, so where you upshifting or you are downshifting. And here it will show you the mechanism on transition from shifting or upshifting. Yeah. So those are the behavior you define during your system architecture design. And then after that, you define what we call supporting implementation. So basically, during your system architecture design, that's the time where you need to provide sufficient details to enable the hardware and software and mechanical design. Because at this level, you say, how do I want to architect my system? Because you know all the requirements. Now, how do I allocate? So the allocation of those requirements to subsystem, and you need to support now to provide sufficient details. Yeah, so you have allocated the requirement, but you need to provide sufficient detail so that you can start to categorize hardware, software, and some mechanical design. And then you need to ensure that there is a bidirectional traceability. So we know that the input to the system architecture is the system requirement, high-level system requirement, which means from the system architecture, we should be able to trace back to the high-level system requirement. Yeah, either from high-level system requirement, we need to go downwards to the system architecture, or from the system architecture, I need to go to high-level system requirement. So we should have bidirectional traceability. So now, so what are the activities which is required as per ASPICE during the system architecture design? So the first one, I think I mentioned about this, is the system decomposition. And in the system decomposition, basically you break your system into small subsystems. Yeah. And that's where I mentioned before that you identify what the hardware, software, and mechanical should do. Yeah, so this is the breakdown, for example. So the input could be, as I said, is a system requirement. So you may have a system requirement which says the vehicle shall support both AC and DC charging, or DC and AC source, yeah? And another system requirement, it could be that the vehicle should operate between -20 degrees C to 50 degrees C. So that is your input to the architecturing your system. So now, knowing this high-level system requirement, you may say, oh, in order to achieve this, then I need to have a couple of the components. So it means I may need to have a battery management system which will help me to control and manage the temperature of the battery, as well as the state charge of the battery. If you remember, I mentioned about that terminology. I may need to have a motor control unit. I may need to have a transmission control unit. And then I may need to have vehicle management system to control the brake and the throttle and interaction. So in this case, you can see here, based on this high level requirement, now we came up to define as an output of the architecture that what are the subsystem will come as a result and what are the interfaces, yeah, to allow the data exchange between these subsystems. So in this case, for example, you could see like, okay, you got the battery, motor, and transmission. This they could be the physical hardwares, and these could be the ECU. These are the control units. So these are you are writing it in software for this. But the thing is like, how do we transact the exchange of battery management system information to a motor control unit? This we could define a mechanism or data exchange protocol to be via CAN bus. So it depending on how quick you want to transfer that data. So which means that as a part of this during your system architecture activity is to have the interface definition. So moving on, another thing, activity is interface definition. I think I mentioned that, which means basically you specify the communication protocols and data transfer and signals. So there are multiple protocol for communication. For example, we have LIN. So from your sensors back to what we discussed on, but back to link back to your cause of 211. You may have data come from LIN, but traditionally from your DC-DC and OBC, usually we use CAN. CAN is faster than LIN. So LIN data transfer is much slower than CAN. So CAN network is faster. So which means you may have from a sensor, different sensors. It could be voltage sensor or it could be current sensor. Then we may use CAN network. Yeah, for example, from chassis systems. Yeah, and then you may have LIN for some other messages as well. And then we have other type of comms like Ethernet. So this is fairly faster, and most of the OEMs now we are moving towards the Ethernet. Yeah. So you define these interface and how you exchange the data. Okay. Moving on, during the system architecture design, another activity is behavior modeling. Yeah, those are the part of your system architecture activities. And then in case there you say, okay, I think I mentioned about the state machine, or it could be sequence diagram. So in here, for example, you may simulate through an activity diagram of saying that, okay, I want to regulate the temperature back to the heating and cooling system I mentioned on the heated seat. So you could have your cabin where you say, okay, you want to heat or cool. So you could simulate that and model that using tools. So we have specific tools. So for example, this is CATIA Magic. So you could model that, and then you could simulate, put the temperature you need, you prepare the system, you do some comparison, what's the target required, and you see if you achieve enough cooling, and so on. So that's what allow you to simulate the system behavior through the activity diagram. And moving on, another activity on system architecture design is the requirement allocation. You allocate the requirements, and which means because you have already come up with the components, you need to say which requirement go to which components. Yeah, and then integration strategy, how does those requirement interacts, and you define how the subsystem will integrate and be tested. And compliance. So the compliance is a key aspect. I'll touch towards the end of the presentation. So you need to make sure that these architecture you define is also compliant to ISO 262 or other regulations as well. Okay, so ISO 262 is the standard using for electronic system in automotive. So we have finished system engineering. Just to recap, in system engineering, I started with requirement elicitation. And in the requirement elicitation, I mentioned that in here, the main objective is the need of the stakeholders and what the stakeholder is expecting and what is basically is the outcome. Yeah. So you start with the need of the stakeholder, what is expected, and what is the outcome. Yeah. So that is the in the requirement elicitation. On the other hand, the system requirement. So this is for unstructured. It's not very structured way. It could be some simple stuff through interview. Whereas in the system requirement definition, now you have a structured and formalized way of saying what the system shall do. Yeah, so what the system shall do comes at this stage. Here is what the customer needs. And then I talk about the tools required for requirement management. And then I mentioned some couple of tools like DOS, MSOSA, which is sorry, the DOS and TRM and Simulink as a tool which I kind of showcase. And then I move into the system architecture design. So it means in the left side of the V, so we have finished the top part, and in the top part, we look on this system engineering activity. So once you have finished the system engineering activities, it means now you have outputs and artifacts to give to the software team now to turn those requirements into the software which can be deployed into a vehicle.
Dr. Hoffman.